crack me, I wanna feel your body. Okay, let's look at the challenge. So explore this binary and try to find a solution using Ghidra. Ghidra can be useful, blah 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 blah. Okay, so this challenge I had quite a trouble solving during the competition because I really wanted to solve it using anger, but for some reason I'll explain later, it was having some trouble. So let's take a look at the challenge. So I already have it here in my folder and I pre-opened it here, so we can save some time here. So yeah, as I was mentioning, anger isn't perfect, like it can't solve everything. There's some edge cases and I'm not sure why exactly it's failing, but I think I have a pretty good idea or a pretty good guess. So if we take a look at the main function here, we have a bunch of crap here. We don't know yet what it represents. So here param1, param2 is the command line parameters. So let's say we're calling Crackme here and something, so something. So it's gonna take the first command line parameter. So the first one I think is the number of arguments. It's like RGC and C. So it's checking if there's at least two. So the first one is the name of the program, right? So the second one is with the first real argument, and then the param2 is the actual argument, right? So there's an offset, I guess, to get the second one. So this probably is it's not a long, it's a character array. So, or is it like a car star star? Yeah, okay. So yeah, it's our int RGC here. So this is fine. So this is a char star star. So it's taking the first command line, well, not the first, the second one, but zero index is the first, right? So this is like the flag we're passing to the program to validate as a pass, and we can see that the completion is spoiling the answer. So we have that covered. So it's taking the first, the second one, and copying it in this variable, like and specifying a buffer size here. So we have user input here. So let's rename it to make everything clearer. So we have our user input, a bunch of constants, and now we're reaching this crucial part. So we're using Scanf, that basically is a function that is used to like parse the string a little bit like regex, but instead using the C format string format. So it can use like %d to match decimal value, %x to match hexadecimal, and %s to match a string. So we're trying to match this format against our user input and storing each of the matches in the specified variables. And the value that is returned is the number of successful matches. So let's first rename this so it's clear. So this is the int part, let's say. This is the x part. And this is the string part. So like I mentioned earlier, like anger couldn't solve this problem. And my guess is that it's not sure how to handle the scanf. So basically it's trying to infer the user input, but then it has to like parse this, and then like it's more complicated when you're doing symbolic execution to like have this parsing stuff. I guess, like, I don't know how the internals of anger work. It's a pretty complicated program, but I think this is what's breaking it. So this is the number of matches, right? So we have this here, it's checking that it's equals to local 1c4, which is a constant, so we can just rename it by like the value. So matches equals 3. So it needs to match like each part. And then here there's like a bunch of formulas. So there's a first if here, then there is a second nested one, then there's like more stuff here. So here right now there's weird stuff happening, and I'll show you why. So right now it's considering the string part to be a character right here. So not a character array, not a string, a single character. So it has a hard time like figuring out like what the code means when it thinks this is a character, but we can help it. So since we know we're parsing a string here, we can retype this variable to be a character array. So let's do that and you'll see what happens. So character, we can specify a random size because we can't have like a dynamic size. And here now you see that the indices are correctly like represented. So we check like this value equals to this and so on, so on. So what I did to solve this problem is like take one small part at a time and like try to solve it by hand. So it's a little bit less fun than doing it automatically with Anger, but it's doable. So let's do that, shall we? So we can open up like a random code editor and like copy like each if individually. So let's just start with the first one, shall we? All right. So we have this. The matches equals 3 we don't care about because we assume we have the correct format, right? So we can just like format it by hand like this. So we have this. So our int XOR this value bit shifted by local 1C8 and this. So actually I'm going to do a few extra renames because this is a constant. It's equals to 2. So I'm going to rename it to 2 here. We have the same thing with 1C0 here is 4. I'll rename it to 4. And do I have a reference to this? I think not. And cvar0 here, if we check a symbol, it just returns x0, x21. So we could like rename it to that if we wanted to. Go back. Okay. So do we have anything that's clear? Yeah, it's fine for now. Okay, so let's copy this again. And now we have a little bit clarifications. So this, let's put some indentation to make it easier to read. So we have int part XOR this bit shifted by 2 and 0x1f must equal to this. So first we can figure out what the bit shift value is. So we can evaluate 2 and 0x1f, right? So I'm gonna put it in the Python console here. So if we do 2 and 1f is going to give us 2, and we can look at 0x1f in a binary form and it's just like a 1 1 1 1. So I think it's just like a bad obfuscation that would make code less clear, but we can just rename this to 2 right here. And like bit shifting to the left by 2, we can just like remove this and like bit shift the equality by 2 to the right. So it needs to be equal to this, right? So if we want like something XOR this to be equal to this, we can like invert the operation and like XOR 0x90 by this to find the answer, right? So let's do that. So let's XOR that by that, and it gives us an integer. We can find we can just take it as an int, right? So if we do it equals 999. So this challenge is just gonna be like a bunch of like hand solving like this. So maybe there's not many things to learn, just like knowing how to like simplify. And so you're free to like not continue watching because it's a bit boring. I won't judge you. So we have this. So to verify our answer, we can like take our original like formula and try like seeing if it equals output, right? And as a quick like check, we can just do the reversed XOR, right? So XOR 0x1737 should give us this, but if we put it in hex, it should give us this. Okay, it looked correct. So just as a sanity check, let's take this again, right? So let's, we don't have to cast to a byte. Okay, so our answer is answer, right? So if we do 96951 XOR bit shift by 2 and 0x1f equals to blah 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 and some false. So what's wrong now? Don't do me like this. I think I had this mistake before. So what's the problem? Oh, right. So this is a big mistake actually I did. So I just removed the zeros for bit shifting, but that would mean like dividing by 16, right? Not dividing by 2. So if we want to actually like take this and bit shift by 2, it's gonna give us this. So the actual formula is like so. So this is why you need to verify. 8, so change this to so now let's verify again. So we have 2 1 5 2 3 XOR this 2 and 0x1f equals to this. False. Come on. 6 3 2. Did I make a typo? $28. What the hell? What's the error? Why? For real though. Am I retarded? Let's start from the beginning, I guess. End part or this, that. So this is the same as this, right? Is the same as. Did I just do like? No, I didn't do any stupid stuff. Oh yeah, I put a 5 instead of a 4. Okay. So let's keep this actually. We're gonna get there. So 2 0 1 5 2 7. Okay, now we can test our formula at last. 2 and should give us something converted to x. Just give us okay. Our answer. So we have our int part, right? So we know that our flag is going to be like something like 2127 and xx and xxx, following the format that is described over here. So now we just do the same thing with the other ifs. Let's do it. So so we done by hand to make things more readable. So we have int part, so our previous answer XOR this stuff. Now this simplifies to 3 since we have a mask of 1 1 1 1. I don't know why we put it like this. And XOR so we have two shifts and a or in the middle, right? So if I'm not mistaken, we can like XOR this by the int part and like find out the hex by like taking the left 3 bytes and the like right 29 bytes, because this is 29 here. If we like evaluate it in our Python console real quick, but so we can simplify that to 29. So we can see like the 3 and the 29 play nicely together. So we have like our 32 bits like this, and when we shift 3 we're gonna like just keep this, and when we shift the other part by 29 we're just gonna keep the right 3 bits and put them at the end, right? So we can take this and XOR it by our int part to like isolate this. So we have like dfdab to c XOR int part. Let's try not to do typos this time. So we have this, we can represent it as binary. So we have this huge binary string, right? So when we shift it by 3, we lose the right 3 bits and we gain those ones, right? So it's gonna be something like this. And when we shift by 29, we're gonna lose the 29 first bits. So something like this. And we're gonna just keep the 3 ones at the end like this. So the answer should be this plus this right here. So I think this is it. So we can parse it as an integer. So let's do like this, base 2. So this, but we needed an x. And if I didn't make any mistakes, I made a mistake somewhere. Thank God for mistakes. Okay. So maybe this is not legit right here. The dfdeab2c. So I remember this is not how I did it. I want to see if it simplifies, but XOR this or this equals this. If we XOR this part, if we XOR both sides, it should be equal, right? Is this 32 bits? Yes, it is. so what's the issue then? Gonna take a while to debug this once again. Hooray, 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 hooray. Did I make a mistake by XORing here? So, wait. Okay, so 20157 is our answer for the previous part. So, one thing I forgot to do is actually check this is the correct answer, right? So this is how we would check that is using GDB. So let's GDB Crackme. So we want to jump to the address that does the check, right? So if we run, we want to see where we. So this is checking that we have at least, we have more than one command line argument, so it's gonna fail, and we're gonna bring to the end of the function, and we're gonna fail and finish, right? So we can run with like flag and tool xxxx. So now we should get past this part. The jump is not taken, perfect. So we want to reach the next compare. So this is checking that there's three parsed argument from the scanf. So we're failing because I didn't put the correct format. So we can run once again. So like something like this, BCD. Now we should get 3 arguments. So not taken. So this is the one that checked. So it compared EDX to EAX. So EDX is like the first 32 bits of the RDX register. RDX is 64 bits, right? And EAX is 3 as well. So they're equal, it's fine. So we'll keep going. Now it's going to compare EAX, which is this value. And I put in 1, 2, 3, 4, right? And we can look in the Python console. df94. Did I put that in? Apparently I did. Or I forgot what input I put in. EAX, but apparently that's what I put in, so it's gonna fail, right? So jump is taken. So let's try our 210527 to see if it passes. 210527. So it should give us hex 98000. And not forget to respect the format. So this, okay. So n next. So string copy. We have our scanf. We have 3 parsed arguments, that's fine. Okay, so now let's look at EAX. So it's the correct value, so it's not taking the jump, so it's going to the next if basically. And now keep going, and it's df DE8B2C. So we have this, right? We could try like verifying if it works. So int part is like 2157 XOR. Could use variables, I don't know why I'm doing it by hand. And the next part is possibly this. I know it's not because I remember it being different, but expart bitshift2 expart bitshift9. I've messed that up. Oh no. So it gives us this crap, which pretty sure it's not what we're looking for. Oh, I mean, Of course it's gonna fail because in Python it's not gonna be limited to 32 bits, right? It's gonna just keep going to a bigger number if we keep bit shifting. Yeah, so that's that. You have to do it by hand, I guess. So okay, so screw it, screw all of that. I'm gonna take like x part as a bunch of x's. I'm gonna take the binary form of int part. Actually, this is gonna be like what's inside there, right? So x equals to this, and this is x, right? So we have the binary form of int part. I'm gonna like insert a bunch of zeros until we match that. So we XOR this and this equals to, maybe I reverse the bitches, that's probably it. And if we do, hopefully I don't get a typo. Equals to this. So if this XOR this equals to this, we know this XOR this. We can basically just reverse the equals to this. So we can do the XORing by hand. We can like 0 x 1 1 1 0 1 1 1 1 1 1 0 1 1 1 0 1 1 0. Make sure not to make a mistake here. This 1, the 0 0. Okay, so this is this part right here. So we know what? I think, yeah, this is the first part of the x part, and this is the end, right? Because if we bit shift by 29, the last 3 bits are going to be here, and if we shift by 3, we're going to have this there. So this should be our answer. Maybe. So this, and not the... Yeah, this is more reasonable, I think. So convert it to hex. Feed code. Okay, we got it. So when I saw this and when I was solving the problem, I was so happy because like clearly a human made this. So I was like, oh, yeah, I'm on the right track. So I know this is correct because I've done it before. But if you want to verify, you jump into the GDB and step to the compare and check like if it doesn't take the jump, and then you're fine. So we have one more part of the problem, and it's this one. So CVAR is 0x21, right? So we're gonna copy the if once again. And then by hand. I think I took one too many. Yeah, okay. So indent, 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 indent. So we don't have to do this, I guess. So yeah. So when you break it apart into pieces, it becomes a little bit simpler, right? So you have like the first character plus minus, so this is just a minus, right? is equal to this, so we can like move this around and plus 0x17, then we have this. So this is 4 bit shifted by 4, right? Because the mask is just gonna leave it like this. So 4 bit shifted by 4 is 64. So that's in the ASCII range, so it looks good. And this is a bunch of crap, right? We don't care about the casting, we can figure out ourselves. So string part 6, I wasn't so sure about. Like, what is that? So I think I just left it as 100, and if needed, we're gonna like brute force it. And string part 4 is the null terminator. So like string part 6 is not part of that array, so it's another variable really. We can maybe take a look at. So it's part of the user input, right? So if I'm not mistaken, it was equal to 0, and 100 is part of the. So let's do it one step at a time, right? So 0x21 plus 0x59, this is a Z. We have a 9. Car 64 is this, and this, okay? So that would, as a final answer, it would be 2 100 this feed code. We remove the 0x because it's still in the problem statement, like here. And yeah, you have to put it in capital letters as well. And let's try it here. Good password, so we got it. 30 minutes. Awful, right? So this is the pleasure of reverse engineering by hand. Imagine if Anger was able to do it. It would take like 1 second and we'd be done. And yeah, sometimes you have to do dirty work, and it's a good way to learn, I guess. Like all those small mistakes I did the same mistakes during the contest and I didn't learn from them, but maybe you will. Hopefully you enjoyed. I did. a little bit. Yeah, so take care.